Hey all, so today we're doing the 7.2 notes, and it's just the inverse of the trigonometric functions continued from 7.1. So we're going to start with 4 examples and then add a little bit more new stuff. So the first is find the exact value of sine of the tan inverse of 1/2. So remember, you want to work from the inside out. So we're going to say, let theta equals tan inverse of 1/2. And remember, tangent for inverse is between negative pi over 2 and pi over 2. So that's like your first and fourth quadrant. And since what we're given is positive, so tan theta is greater than 0. Therefore, this would be in quad 1. So we're going to draw a triangle. And tangent is opposite over adjacent. So 1 over 2. We're going to use Pythagorean theorem. So 1 squared plus 2 squared equals c squared. 1 plus 4 equals c squared. 5 equals c squared, so square root of 5 equals c. And now we're trying to find what is the sine of this triangle, and that is opposite over hypotenuse. So sine theta equals 1 over square root 5, but you can't have that radical in the bottom, so equals square root 5 over 5. Okay, next one is find the exact value of cosine sine inverse negative 1/3. So theta equals sine inverse of negative 1/3, or sine theta equals negative 1/3. I don't know why my pen's doing that. Change this and see if it fixes it. And then remember that the restriction for sine inverse is between negative pi over 2 and pi over 2. So again, the first and fourth quadrant. And right now we have the sine of negative 1/3. So sine is negative in that fourth quadrant. So we're going to draw our triangle in the fourth quadrant. And then it's sine, which is opposite over hypotenuse. So negative 1 over 3. And your hypotenuse is always going to be the positive one. So since sine, so now we're trying to find the cosine of this. And first we need to figure out what that missing side length is. So we're going to use Pythagorean theorem. So negative 1 squared plus b squared equals 3 squared. 1 plus b squared equals 9. B squared equals 8. So b equals the square root of 8. So that means cosine is the adjacent over the hypotenuse. So cosine theta equals adjacent over hypotenuse, so square root 8 over 3, and then just our last step is to simplify the square root of 8, which is 2 root 2 over 3. So cosine theta equals 2 root 2 over 3. Next, we have find the exact value of tan of the cosine inverse of negative 1/3. So theta equals cosine inverse of negative 1/3, or cosine theta equals negative 1/3. And then we remember our restriction on cosine inverse is between 0 and pi. So the first and second quadrant. So we are given negative 1/3. So when is cosine negative? And that's in that second quadrant. So we're going to draw a triangle in the second quadrant. And the cosine is negative 1/3, which is adjacent over hypotenuse. And then find that missing side. And we found from the last one, the missing side length would be square root 8. So now we need to find the tangent. And remember, tangent is opposite over adjacent. So square root 8, so tan theta equals square root 8 over negative 1. We're going to simplify this and say tan theta equals negative 2 square root 2. Okay, last example, we have find the exact value of sine inverse cosine 5 pi over 6. And the first thing is we're going to do the inside. So the cosine of 5 pi over 6 we already know from our unit circle. So sine inverse of 5 pi over 6, we can write that first. So the cosine of 5 pi over 6 equals negative root 3 over 2. So we're going to plug that in. So sine inverse of negative root 3 over 2 equals theta. Or sine theta equals negative root 3 over 2. So when does sine equal negative root 3 over 2? So remember, this is restricted between pi over 2 and negative pi over 2. So we can think sine equals root 3 over 2 at pi over 3. And then to make it negative, we just say negative pi over 3, since it would be in the fourth quadrant. So because this lives between, the sine inverse is between negative pi over 2 and pi over 2, this would be quadrant 4. But we're using from pi over 2 and negative pi over 2, so we're just going to minus that pi over 3. So theta equals negative pi over 3. All right, next here's just some more. We're going to look at the inverse of secant, cosecant, cotangent. They're really kind of like the same as the other ones, where we have some restrictions on them, and we're going to use those and apply them in problems. So let's do this first one. Find the exact value of cosecant inverse of 2. So we're going to say let theta equal cosecant inverse 2, or cosecant theta equals 2. And then cosecant from these notes above is between negative pi over 2 and pi over 2. And remember, cosecant is the reciprocal of sine. So if cosecant theta equals 2, that means sine theta would equal 1/2. And then where does sine theta equal 1/2? And that's at pi over 6. So therefore, theta equals pi over 6. All right. And then the last two, we're going to be using our calculator. So we have the secant inverse of 3. So we're going to say theta equals secant inverse of 3, or secant theta equals 3. And then remember, secant is the reciprocal function of cosine. So if secant equals 3, cosine equals 1/3. And so we have theta equals, we're going to use cosine. So theta equals cosine inverse of 1/3. And so we're going to go plug this into the calculator. So home, we have the inverse, so shift cosine, and then 1/3. Enter. And then I have to make sure which settings I'm in. I want radians, home, put the same thing in, and I get theta equals 1.23. So I'm going to put a big note here. Radians in calc. So theta equals 1.23. All right, last problem. We have the cosecant inverse of -4. So theta equals cosecant inverse of -4. Or the cosecant theta equals -4. And then cosecant is the reciprocal function of sine. So sine theta equals -4. And then to figure out what theta is, we're going to multiply by the sine inverse. So then theta equals sine inverse of -1/4. We're going to go plug that into the calculator. So shift sine -1/4. When you get that, that equals -0.25. So theta equals -0.25. All right, let me know if you have any questions.